Hello, everyone, and thank you for attending our webinar, Scale Enterprise Level App Security that Adapts with Your Business. I am your host, Mindy Stubbs, Demand Generation Coordinator here at Optiv. Before we get started, a few items of housekeeping. First, this webinar is recorded and will be available at any time for on-demand viewing. You can see here on the console that we have several resources you can use during or following the webinar. This includes some resources we think you'll find valuable when it comes to your security program. We also have our full speaker bios and social sharing buttons. On to the webcast. Let me take a quick moment to introduce our speakers, Phil Brass and Marlon Machado. Phil Brass has spent the last 20 years dedicated to information security. Phil has been with Optiv since 2009. Currently, he directs Optiv's 40-person application security consulting practice. In his role, he is responsible for offering development, strategic direction, and working with the clients to solve the problems of complex application security programs. Marlon Machado is the worldwide standardization leader for application security sales at IBM. Marlon has helped IBM launch the project to bring the first fourth-generation conversational collaboration platform to market. And now he works with companies, big and small, around the world to show application security is something worth investing in and that they should do so with the IBM Security Immune System. Now, let's get things started. I will hand it over to our first speaker, Phil.
Thank you very much, Mindy, and thanks everyone for tuning in. When we talk about, enterprise scale applications, a lot of times nowadays we're going to be talking about DevOps type development practices, and DevOps development practices present a lot of interesting challenges to your typical application security team. We get a lot of questions from our AppSec partners at our various clients saying, hey, these guys, my team is moving over to DevOps. They're going to be moving a lot faster. So I want to talk about DevSecOps, or, sort of putting security into a DevOps context. And to kick that off, I figured I'd give you guys a little overview of what DevOps entails. Probably the primary goal, or one of the main features, I guess, of DevOps is a reduced lead time. The lead time in software development, especially for modern applications on the web and mobile, the lead time is the amount of time between when someone comes up with a concept that they are going to put into the application and the time when that concept is implemented and in production. And if you think about that, in the 5-10 year ago context, that lead time was, often 3 months, sometimes 6 months. If you were really lucky, it could get squeezed down into like a monthly release cadence. And in the DevOps environment, we want to squeeze that lead time down much, much smaller, down to a week or less between when an idea is conceived and when it gets turned into production. And the reason we want to do that is because we want to explore the space of value. How can our application deliver value? If we go taking large leaps, we don't deliver a new set of value until 3 months from now, the market can move, our competitors might move quicker than us, and we might take a giant step in the wrong direction. So by taking lots of small steps, we can feel out the gradient. One of the ways application teams do this is using A/B testing, where they'll maybe develop some ideas. They'll say, let's put this one into production, and we'll let maybe half of our users or 10% of our users try out the new functionality and see if they get more value or if they deliver more value to us. So those are some of the features of DevOps and why it's done, and sort of what the point is, right, is to use hypothesis testing and small incremental development changes to really feel out the value space. But we have to do it very quickly, and we take smaller steps. One of the key tools that is used, or the way that we get lead time reduced, is that we look for all the bottlenecks and we eliminate them. So this is really something that came from lean manufacturing, and the idea is just you study how you do work, you identify those things where you're just spending lots and lots of time, and you find ways to make that bottleneck go away. The other thing that we try to do, because we want to take small steps, because we want a lot of visibility into work, is we try to reduce how many things we're taking on at any given time. The amount of work in progress should be slow. And you'll see that in things like Kanban and Scrum methodologies as well. So that's kind of an idea from the Agile side. So some of the bottlenecks that we're seeing, for example, you would develop your application and then you'd say we're ready to hand off to the QA team. First of all, just handing off to a different team is an organizational bottleneck, and you have to have meetings and coordinate and a plan, and we agreed we would hand off tomorrow, but now it's going to be next week. So there's all kinds of friction at the interface between teams. One of the things you see a lot in DevOps is integrated teams, where there's not that much difference between developers and testers, or maybe the developers are the testers. They write their own unit tests. But the other thing that we see is the use of stuff called continuous integration, where we build out an automation platform that automatically builds. It automatically pulls from our source code repositories, automatically builds, automatically runs integration tests, and gives us a green or a red. And if there's a problem, it kicks it back to the developers and says, you guys aren't integrated right now. So the idea is that the code is always being built and is always maintained in a buildable state. We also see continuous delivery practices which go a step further. And they will often use cloud-type services and infrastructure as code to construct a deployment environment. Even if it's not a production environment that's exposed to the world, we're creating a simulacrum of production, something that's as close to prod as possible, and we're going to deliver the software into that environment and run some more tests, maybe some scalability tests. Maybe we do a little chaos engineering and disrupt it and test the resilience, etc. And we do that continuously. So all of these things are done and controlled by pipeline tools. And to the extent possible, we do these things in a self-service method. So we're trying to step back and let the development teams own the automation. But you can tell, as we talk about this, that there's a lot of automation going on. We use infrastructure as code to do this deployment stuff. There's also a lot of other intriguing technology that gets used, clustering systems, service meshes, and things like that really allow us to be very flexible in how we do those deployments in an automated fashion. But what really ends up happening is there is a lot of extra software being used to make our software. So one of the key challenges that we end up with in application security is that we represent a bottleneck. If you look at how traditional application security work is done, you bring in someone, you've got your application that's just about ready to be released, and now you say, hey, we have a gating factor, we need to have the application tested. You bring in someone to do the testing, someone from your AppSec team. They come in, they use a variety of tools, they do a lot of manual processes. It takes them, anywhere from 3 to 10 days, and then they spend a little while writing a report about their findings. So, a month later, you have a nice report that says, yes, this application is ready to release. And that certainly represents a significant bottleneck in a process where we're trying to go from, releasing twice a year to being able to release, once a day, 3 times a day, certainly having week-long lead times between conception of ideas and implementation in production. Taking 5 days to do a test and then another 5 days to write a report is too long. So one of the risks is that as teams move to DevOps, they identify the bottleneck and their solution is just, we are going to run the scanners and that's it. You certainly should have, and you need to have, tools like AppScan in the process. They represent a very important baseline of security testing, and they should be integrated into your continuous integration and continuous delivery systems. In addition to that, though, you need to think about all of the extra testing that your testing staff was doing, the security testing that was, focused on higher levels of business logic, that's focused on exploring the frameworks and things like that, all of the different things that they do manually, these are all things that we can actually capture instead of having them done by hand every time. Instead of doing all of that inside of a tool like Burp Suite, we want to think about having those testers start writing test suites in the same way that, quality assurance testing went from originally a purely manual, click on this button, fill this value in this form, and became a scriptable thing of test suites. We want to do the same thing with manual security testing if we need to be in a DevOps environment. Rather than doing it by hand, turn it into a set of test suites so that you can have your 1-week manual assessment that runs in 10 minutes during continuous integration because it was all captured. And it will take longer than a week to capture all of those tests, but at the end of the day, you have a very nice set of tests that cover lots of interesting high-level things like horizontal and vertical privilege escalation and insecure direct object references, and lots of things that are difficult for a scanning tool to understand about what should and shouldn't be allowed to happen. We can capture those things and turn them into a piece of software that runs as part of the test suite. So that's one of the most important things to do as we move into DevOps and we say we don't have time for manual testing. What the response should be is, we're not going to do manual testing, but we're going to have our testers create a test suite for you, in addition to helping you integrate our scanning tools into your pipeline for static analysis, for dynamic analysis, etc. Another challenge that comes up when we look at DevOps is that the automation itself is a large piece of software. And so if our problem was that we're not sure if the software is secure, what we've done now is just added a bunch more software that we are also not sure if it is secure or how secure it is, whether it's set up securely, deployed securely. So we now have Jenkins, and we have Docker repositories, and we have Kubernetes clusters, and we have service meshes and Envoy proxies and all of these kinds of things. We've added a lot of pieces of software to allow us to automatically build, deploy, and kind of automate the software delivery process. And it's important that when we look at application security, we aren't just looking at the application itself. We need to look at the entire set of automation tools that we built around it. The reason is that especially pipeline tools like Jenkins and things like that, they are in control of a lot of important hefty processes that have lots of serious permissions. When you are able to click a button in your tool that spins up an environment in AWS, right, it constructs a large number of virtual hosts, in EC2, or it does large deployments into your Kubernetes cluster. That's a lot of power that we put into a single piece of software. So that software needs to be audited as well. You need to make sure that it's been deployed securely. You need to make sure that you're testing it in the same way that you were testing the application itself. There's a lot of power there. Those things can easily take down your production instance, for example. So the automation platform is another area that you need to not neglect when it comes to one of the challenges we see from DevOps. We've introduced, 5 to 10 very large pieces of software into our processes. We need to make sure we keep them under observation as well. One of the last things we see, the whole infrastructure as code idea is vitally important, and immutable infrastructure is a great way to really help control some of the operational problems that we used to see with special web servers, where, we can't really take that thing down and patch it because we've never been able to replicate that web server. And turning the creation of a web server into a set of scripts that always runs the same exact way, that always produces the same output, it lets you scale up. You can just generate like 10 of those web servers now. It's easier to scale. So it's a very valuable idea. The challenge is that if you hand all of that infrastructure generation over to a set of application developers, they're not always the same people as the people you guys have had in your infrastructure operations teams who know how to build a secure environment for applications. They know how to set up, secrets repositories. They know how to set up firewall rules and IDS rules and things like that. So with developers who are great at developing applications, they might always be the best at figuring out how to securely manage their AWS accounts, at knowing how to securely construct a set of firewalls and firewall rules that will only expose the necessary services, etc. So it's important to keep an eye on the infrastructure as well. It's great that it got turned into code and that it's reproducible and scalable. Those are very important attributes. In order to make sure they're also secure, you need to get some of the expertise from your, secure infrastructure team and move it into that DevOps team, either on a part-time or a full-time basis, so that they can help them build secure infrastructure as code. And that can stretch all the way from just figuring out your network construction to, if you are generating, AWS EC2 images from like an image bakery, figuring out how to make sure that those are always locked down, that they have all of the latest, SE Linux policies applied, and spending a lot of time there. The nice thing about having massive scale is that a little bit of security effort at the beginning means that when you do have 10,000 of these web server images out there, they're all based on a very, very secure kind of gold image or gold image code, right? It's not even an image, it's infrastructure as code. So you wrote a bunch of scripts and you know that they produce a nice secure output. So that's a very important feature of the, or a very important way to respond to one of the other challenges we see from DevOps. So on the next one, one of the ways that we see a lot of organizations responding is you look at the Gardner Def Setup model, and this is a great image that kind of shows a lot of the different areas we want to look at, from secure design, looking at your requirements and threat modeling and your coding practices and getting all of that kind of buried into the team before they start practicing DevOps, looking at all of the things that are going to be outside of the application, from your network layers and from your WAFs, your container and your infrastructure security, looking at how you're going to do monitoring. And one of the real benefits and opportunities we see in the DevOps culture is a huge focus on monitoring. And security, as you bring security into DevOps, you really need to participate in that. One of the challenges we see a lot of security organizations facing is the sort of idea that security information should be siloed within these security teams. What you really want to do in a DevOps environment is make sure that at the very least the engineering team has good visibility into the threats that have been facing the operational environment. And that means taking information from your security monitoring systems and putting it on those engineering dashboards. The more your engineers see how their app on the internet is getting attacked, the more aware they are, the more interested they are in how to defend against those attacks. So by pushing that information back into the development team, we're going to inspire the developers to say, you know what, I really need to worry about this because there were literally 20 SQL injection attacks against our application yesterday. Maybe we should be researching how to make sure we're really not vulnerable. So it really becomes kind of a virtuous cycle of getting that information in there and the developers wanting to be more secure because they understand that they really are facing threats. And then, on the verification side, there are a lot of different tools you guys want to be looking at, from looking at your software composition analysis. Applications these days, I think I saw a statistic that said they are 90% open source, right? Because you import a couple of dependencies, but each of those dependencies incorporates a couple more, and before you know it, you literally have 1,000 modules that you didn't write supporting your one application, both on the server side and on the client side. So being able to understand that composition, where all those things are, how they're licensed, and in particular, if you have the most up-to-date version and if there's any known vulnerabilities, that's very important. Bringing in a good set of application security testing tools, in addition to writing your own application security tests, Conducting the right level of fuzzing against your application can be an important component of verification, especially as you're looking at applications that are non-traditional apps, things that aren't like IoT applications. They definitely can use a lot of fuzzing. Your Java web apps, fuzzing is a little different in the web environment, and it's really handled by a lot of the application security tools. And then at the end of the sort of assessment chain, having a tool that can pull everything together, like a CodeDX or a Kenna, something to take all the information in from all of your different assessment tools, deduplicate it, and serve as kind of a working area for you to eliminate false positives, prioritize the risks properly. A lot of tools will spit out a default risk, but really it depends on the context, right? And so having some place for your AppSec engineers that are on your DevOps team to be able to really look at those things before just automatically pushing them off to the engineers to fix is a very important step. So we find a lot of value in this model. It's a great diagram to look at. So I want to talk a little bit about our offerings and what we are able to do for DevOps teams. I have a team of consultants who do a lot of DevOps work. And one of the things we're able to do is real reference deployment. So because we do so much testing work and use all of these tools, and in many cases are trained on them, we are able to come in and set them up in a way that someone who doesn't run them all the time might not have the same ability to do. And getting the tools configured properly, there's really two great challenges in using AppSec tooling. And one of them is making sure they're set up right, and the other is, sort of parsing and evaluating the results. And that's why you need expertise on your tools. Certainly in terms of getting them set up properly, we have a great team that's able to do that and really build strong reference implementations for you. We are also able to get, once those tools have been set up and they're kind of well configured for your applications, if you're looking at how to integrate them into a pipeline and how to integrate them into the your triage tools like Kenna and CodeDX and things like that, that's absolutely an area where we've done plenty of work. So we'll kind of look at what you've got and figure out how to make all the pieces talk together. Sometimes there's plugins. Sometimes the plugins don't work. I'm sure some of you guys have run into that challenge. We see it all the time. So oftentimes there's custom development needed to get it really running smoothly. And that's something we're able to offer. In terms of helping you with your SDLC programs and kind of building out your processes and improving really your maturity level, that's where we can help as well, helping you getting those tools into the system, helping you, drive education out to your developers so they know what to do, and figuring out what the right tools are for you. So, really, that's kind of the DevSecOps story for us. So it's integration, implementation, helping you design those pipelines, helping be that that interface between the DevOps teams and the security teams if you are broken out that way, and also really helping give guidance at a higher level if you're interested in understanding at a deeper level what the challenges are and how to design the organization itself. We can talk to that as well. At a higher level, these are really the main offerings of my team. We do a lot of assessments, and we test lots of different software, and we test it in different ways. We do code reviews. We do black box testing, gray box testing against cloud apps, web apps, mobile apps, APIs. Diving deep into your microservices architectures, looking at your clusters, thick clients, serverless code reviews. So we do that's a large part of our business. And we also do IoT testing at a deep level, with the whole reverse engineering and, desoldering chips and all of that stuff. So those are some of the assessment offerings. We talked a little bit about our technology offerings just in terms of integration and helping all of the products work together and getting them all set up so that they're optimally functional. We also can help with some program management if you're interested in, picking up something like an AppScan and then making sure that it's being used throughout your organization. We can certainly help give you some talent to kind of manage that process, rolling it out, making sure it's well used, and making sure the results are being, correlated and coalesced. And then the last thing we really focus on is strategy, helping design your program, your SDLC, looking at some of the fuzzier assessment work, looking at your architecture or your design even before you start building your applications, helping with threat modeling, and obviously, we just talked about our DevOps security offerings. So that's kind of my side of the house. Now I want to pass it off to IBM.
Thanks, Phil. Hello, everyone. This is Marlon from IBM, and I am delighted to be here to tell you a little bit about the IBM Application Security Portfolio, and more specifically about the IBM AppScan Family. Our portfolio has been around for a little over 10 years. We do have offerings for both on-premises deployment as well as consumption from the cloud. And what characterizes our portfolio is primarily its simplicity. It's very easy to use, mainly because we have cognitive capabilities. We use lots of machine learning in order to make your lives easier. Secondly, because it's very fast. Our scan engines are very nimble when it comes to running your scans and giving you results. We use, as I said, lots of cognitive capabilities that we have essentially harvested from the rest of IBM. It's the advantage of being part of the company that invented Watson. So we do things like intelligent findings analytics and source code analytics to help eliminate false positives using, a cognitive approach as opposed to just patterns. And very safe. We are part of the greater IBM security portfolio, what we call the security immune system. And that imposes a number of requirements on our products that they need to be compliant with in order to be part of that greater portfolio, that platform. So we can help you. Our portfolio does pretty much everything. We do static analysis, dynamic analysis, mobile and interactive, as well as open source. And we can analyze all application types, from web applications to mobile to desktop applications. And we pretty much give you a risk-based assessment of your overall application security posture, which is very easy to understand by people who are not necessarily familiar with the intricacies of application security testing. It's very easy to understand and to report back to management to say, this is where we are, this is where our applications are vulnerable, this is how we plan to address those vulnerabilities. Like I said, the application security portfolio is an integral component of the IBM Security Immune System. We are part of this triad of application security management, testing, and other parts that do monitoring and protection. We basically take care of application security testing, like I said, with dynamic, static, interactive. Our portfolio has hooks into the rest of the IBM Security Immune System. We have integration with things like Resilient, things like Master 60, and all of the other parts of the portfolio, as well as with other products from IBM, like Urban Code, like Rational Team Concert, and other tools that participate in the DevOps pipeline. Our main focus for the platform is DevSecOps. Our goal is to give you the tools that can help you automate security, application security testing into your DevOps pipeline easily and seamlessly. So developers as well as security professionals can do their jobs. So application security is no longer this burden like, oh man, it's going to slow me down. When deployed correctly, when deployed according to your needs and your requirements, our portfolio basically becomes ubiquitous. You don't know it's there. You just press a button on your IDE, whether it's Visual Studio or Eclipse, and the scan goes where it needs to go. You get the results back, and you get that holistic view, the risk-based assessment of your security posture as you go, and it's cumulative, and then you can run analytics on it. It's extremely useful, not only to developers, but also to security professionals as well as executives that care about these things from the standpoint of the company's reputation, your customers' data, et cetera, et cetera. So let me tell you a little bit about the IBM AppScan family using AppScan. And so these guys go all over the place, trying to remediate things when something goes wrong for one of our customers. The way we do it is we have a very scalable platform. It's a very scalable DAST solution, which is usually the most resource intensive. Our roadmap is focused primarily on improving the availability of cognitive capabilities as part of application security testing. We understand the impact false positives have on productivity. And so our goal is to refine our machine learning capabilities to elevate, to raise the level of confidence when we tell you that something is a false positive. It's because we're pretty confident it is. The other thing that our platform has is that it's extremely adaptable, meaning it fits well within your DevOps pipeline, so you can turn it from DevOps into DevSecOps. Everybody does it differently. A lot of people use, some core tools that you can find everywhere, but at the end of the day, everybody does it differently. So our platform can adapt and can, provide the different entry points into your pipeline to ensure that the code is tested and it's secure when it reaches the production end of the DevOps pipeline. What you get, the other thing is you get flexible licensing, better than most competitors. Our licensing makes our products very, very affordable. More importantly, our licensing model is very flexible, so if your needs change, there is always a way to get what you need without, costing you an arm and a leg. We have floating licenses, we have authorized user licenses, we have term licenses for AppScan. You can actually get a license for AppScan for 30 days if you wanted to. And if you like it, you can renew it for another 30 days. Just like, cloud service, but you control it, you have it on your data center, you decide how it runs and who has access to it. This gives you significant ROI benefits when it comes to once the platform is in place and you start seeing it starts operating normally. The return on investment is very, very significant, and you can see it very quickly. Again, and the other thing is automation. Like I mentioned in the beginning, we have lots of automation. In fact, DAST automation, it's something unique we do. No other vendor does it, and it saves you tons and tons of time and money in the end. Our static analysis, we just added support for Python, for COBOL. Support for Angular and Swift is coming pretty soon. And we are working on improving our JavaScript scanning engine as well as our C++ scanning capabilities. And last but not least, we have unique machine learning algorithms that would use false positives, what we call intelligent findings analytics. This is where, number one, false positives are eliminated from you, so you never see them. And last I checked, we were up to 90% success rate. And then not only that, the must-fix vulnerabilities that are revealed are all grouped into something we call fix groups. And they are linked in such a way that if you fix one, the system understands the impact of fixing the core vulnerability, and it basically reassesses that fix group, and it eliminates the ones that you really don't need to go check because they were dependent on the core vulnerability. So it's really makes life extremely easy for developers. Let me tell you that. This is the AppScan family. This is our topology. You got server components and clients and desktop applications. On the server component side, you have the AppScan Enterprise Server, which is capable, whose capabilities include static testing and dynamic testing. You'll notice there's a black circle and a white circle there. The black one is your typical black box testing or dynamic application security testing. And the white one is for white box testing or static. So the enterprise server, the AppScan Enterprise Server, gives you those two capabilities. You also get the dynamic analyzer, which is our DAST engine, if you will. And then you also get AppScan Source for Automation, which is our static analysis engine. Those three servers work together in order to run your scans and correlate results and do all the things that produce results for you. On the client side, you have the web client for dynamic analysis, which basically takes care of it's your DAST dashboard. You have the reporting. It's also a web page, the reporting page. This is where you see both your static reports, your dynamic reports, and this is where you get that correlation that I was talking about, that risk-based assessment of your security posture. You get AppScan Source for Analysis. This is a desktop client. It's specific to static analysis. This is where you go, look at your specific lines of code that need to be fixed and so on. You also have AppScan Source for Development. This is an IDE plugin that works on Eclipse. It works on Visual Studio, pretty much the IDEs that people use on a regular basis. And then you have AppScan Source for Remediation, which is where you actually fix your vulnerabilities. Again, this is an IDE plugin that also works with your favorite IDE. Next to it, you have AppScan Standard, which is a standalone desktop application. It's a little different, but it's very effective. This one runs scans, both dynamic and static, locally on the machine where it's installed. So this is mainly for security professionals that want to do something very specific. You can use it as a client to the AppScan Enterprise Server, and it allows you to define your policies in a very granular manner, and then submit your scans to the server, and just leave them there, or you can bring them back to your standard dashboard. And it's for security professionals that want to have a deeper, closer, broader view of the application security testing program overall, and understand where each application is. So this is the AppScan family topology. This is what you get when you buy it. And you can install, mix and match depending on what you want to do. Interesting, we were talking about ROI. Forrester Research did a study that it was not necessarily featured it was featured for, not necessarily for the AppScan family, but for the entire portfolio. And the idea was to assess the economic and business benefits if someone acquired the portfolio. But when it comes to the AppScan family, the study found that the estimated ROI in the particular cases that they studied, they talked to a few customers, lengthy interviews. The estimated ROI was 253%. This is when the platform is fully deployed and it's fully integrated into the DevOps, into the software development lifecycle. Not necessarily DevOps, but the software development lifecycle. This is when all the IDE plugins are deployed and all the plugins are configured. This is when it's running in steady state. That, someone has to do it. So once it's there and when it goes, once, developers and security professionals are using it, the estimated ROI was estimated at 253%. That means it's a payback period of just 6 months. That's pretty good. And the cost savings, as accounted, after those 6 months, about 90% compared to when the application security program was running without it. Total savings over $500,000 per year, just in compliance compliance services that are no longer required. So that was very, very interesting. There's a link at the bottom of the slide if you are interested in looking at the study more closely. But it's based on actual use cases, actual customers using the platform. Mentioned that we provide a risk-based assessment of your security posture. This is pretty much what it looks like. In this particular table, each column is an application, and you get your typical the function for the application and what the application does, the type of exposure, whether it's internal or external, whether it stores sensitive information, the level of PCI compliance that it has, the business impact, which is defined by the security team, and then the type of policy, the security assessment policy that governs how this application is tested. You can have multiple policies actually applied to it. For example, we do this particular thing every 6 months, this particular thing at the end of the year, etc. The types of vulnerabilities that are found on any given run, and the overall risk rating, because you may be running a number of static scans on it as well as dynamic. If the application itself has a mobile component, you can correlate that. And that score that you get, low, high, medium, very high, you define what that means. And moreover, it's an aggregation of all the different tests. So this is something you can take to your management. This is something you can take to people who care about the security posture without, caring about the technical details of each individual result, and just tell them where you are, And it's actually very convenient. And we do it, thanks to the fact that we do everything. We do static, dynamic, interactive, mobile, open source, and which allows us to correlate all those results and give you this holistic view of your application security program. Very few vendors out there do this. We have put a lot of work into it because we honestly believe that application security is not just a concern for developers. It is a concern for management. It is a concern for the security teams, and we want to provide the right tools for them to support their decision-making process. Mentioned this a little bit. We are the only ones in the market who do this. It's like having a hacker in a box. It focuses on the highest risk issues. It's based on functional tests, and whenever something gets flagged as high severity, it automatically looks at those, and then it gives you this end-to-end testing flow across multiple layers, multiple languages, multiple technologies, depending on what you're doing. And then you can automate that, and then it just runs. Developers can actually run it at the end of the cycle. It takes advantage of our unique approach that I mentioned for exploiting functional tests, layered scans. That's something very interesting as well. And it integrates into your DevOps pipeline. This is what we mean when we talk about security automation into DevOps, because you don't have to reinvent the wheel. It leverages existing functional tests, to accelerate scans, It gives you a full set of REST APIs that would allow you to automate your scans and enable product integrations and do pretty much everything you need to do. And it learns on best practices. It's based on best practices, so you can actually take advantage of what other people have learned over time. It's extremely useful, and it's freely available to you once you buy the platform. Quick multiple security gates that where the AppScan family goes into. You've got your development gate, your QA gate, your security gate, and this is where the components like AppScan Source for automation, AppScan Enterprise go into place, AppScan Standard, manual pen testing, and so on. We integrate into your development pipeline really easily. We support, like I said, the IDEs that people like and pipeline tools that people like, and it becomes ubiquitous. Like I said, once it's running in steady state. Really quick system on premises. You've got the enterprise server, where this is where you do your enterprise reporting, user administration, authentication, authorization, and all that. You've got AppScan Source for automation. This is basically where you run your scans. AppScan Source for analysis. That's a desktop client. And then, depending on the ID you're using, you will install plugins to Source and for development and Source for remediation. And you can take a look at what each one of those do. This is the ecosystem for on-premises. This is for dynamic analysis, also on-premises. You've got your AppScan Enterprise Server, as I mentioned. This is the one where you do all the things related to reporting. This is where aggregation of data occurs. This is where all the machine learning capabilities are. And then you have your AppScan Standard. Remember I mentioned you could use it as a desktop client to the enterprise server. And this is basically where you control your dynamic analysis scanners. You can deploy as many as you need to, and you can automate a lot of the tasks that go into dynamic analysis. Here's a quick demo of how this works. Let me show you real quick.
Welcome to this short video overview of IBM Security AppScan Standard, in which we'll configure and run a simple scan and take a look at the results. From the AppScan welcome screen, we'll create a new scan, and from the list of predefined templates, we'll choose the template configured for scanning the AppScan Demo test site, which you can use yourselves. The wizard opens and checks the connection to the site being scanned. We'll be using the wizard in this demo because it simplifies scan configuration by guiding you through the basic options. But when you're more familiar with AppScan, you can use the configuration dialog box, which lets you fine-tune many additional settings to the specific requirements of scanning your site. The next stage of the wizard is to record the login sequence with a valid username and password. This helps AppScan identify when it's in or out of session, and also enables it to log into the site if it gets logged out during the scan. When you've logged in, click the I am logged into the site button to close the browser, save the login sequence, and continue with the wizard. The green key icon shows that AppScan has validated the login sequence. In the test policy step, you can choose the kind of tests that will be used in the scan. We'll use the default policy this time. Then we'll start a full automatic scan. No FFW. When the scan's complete, which for a large site can take several hours, the results are presented in 3 views: data, issues, and tasks. Let's take a brief look at each of these views. Data view. The default view shows the structure of the site and other application data gathered when exploring it. The application tree on the left shows the structure of your site with all its explored folders, URLs, and files. You can use this tree to check that AppScan covered the site fully and, if necessary, change the scan configuration so it does. Click on a folder to open it. A node with a strike-through indicates a failed request. Right-click on a node for a variety of options, including Show in Browser, Manual Explore, Exclude from Scan, and a security report for that specific node. When you select a node, in the application tree, the result list shows the requests, parameters, cookies, scripts, and other details that were discovered during the Explore stage for that node. Right-click for various options, such as Exclude this parameter from the scan. The Details pane gives full details of the selected result in the result list. In some cases, you might choose to explore the site only without testing it and then review the application data. When you are satisfied that you have the site coverage you want, you could then continue with the test stage of the scan and then review the issues found. Issues View is the central, most important view. This is where you can see details of the vulnerabilities found in your site. For each node in the application tree, you can see the number of issues found, and in the middle pane, the issues for the selected node are shown with their severity categorized as high, medium, low, or informational. When you drill down to a specific issue, the Issue Information tab on the right offers a number of details about the issue, with a rendering of how the test response looks in a browser and a simulation of any pop-up that the user would have seen. The Advisory tab has a thorough description of the security issue discovered. The Fix Recommendation tab offers suggestions for fixing your site, and the Request Response tab lets you see the actual request sent and response received. The third view is Tasks, which lists suggested remediation tasks arranged by severity to solve the security issues found by the scan. For each task, you can see the issues it addresses and the parts of the site that are vulnerable. AppScan offers a range of customizable reports, including a comprehensive security report and over 40 different templates for industry standard and regulatory compliance reports. There's a powerful, extensible SDK, and our accompanying glass box technology can reveal more information about issues, including identification of the exact problem in the application source code. We've seen some of the main features of AppScan, but there are many customizable options and capabilities that we didn't cover. AppScan is a powerful tool for ongoing risk assessment, both before you deploy your site and once it's live. This concludes the overview.
That was an awesome demo and entire presentation, so thank you so much to both Phil and Marlon. That concludes today's webinar. I want to thank all of you who attended, and thank you to our presenters. Have a great day.